Hello students, this is Prema ma'am here. Hope you all are safe by self-quarantine. Please strictly follow all guidelines for your safety, for our nation's safety. Please wash your hands very often, and if you are sick, please wear a face mask. When coughing or sneezing, cover your mouth and nose with your arm. As students, you can change the nation. Please don't think that it is like holidays. This is the time for enjoy like that. Definitely not. This is not the right time for enjoying. As youth, as students, you should contribute to your nation at your best. Please cooperate government guidelines and try to spread the positive awareness among your friends, relatives, neighbors, etc. etc. Do your best from your side. Definitely somewhere it will help to someone at least. Hope you all will follow my guidelines. Hope you all do your best from your side. And with this precaution note, I wish to start a session through a different learning mode. Please understand the situation and accept this kind of learning. Yes? Don't even let a crisis go waste. We will start. Are you ready, students? We will start? Yes. And already we have discussed the introduction about data structures and we have seen few linear data structures. Yes? What are those? That is stack, queue with its types. And there is another example for linear data structure called linked list. Yes, already we have seen what are the types of data structures. One is linear and another one is non-linear. Yes, under linear we have seen what are the examples: stack, queue and linked list. Under non-linear we have seen trees and graphs. Already we studied enough about stack and queues. Now we will start learning about linked list. Okay. The linked list is a linear data structure in which elements are not stored at contiguous memory locations. What is that? Because we have seen both stack and queue operations with array implementations. Yes, their elements are stored at contiguous memory locations, correct? But array have few limitations. What are those limitations? Number one, the size of the array is fixed. We have seen already. That is what we did in programs, because we must know the upper limit on the number of elements in well advance, correct? What is slow insertion and deletion? Second one is slow insertion and deletion. Because inserting a new element in an array of elements is quite expensive, because the room has to be created for the new elements, and to create that room, existing elements have to be shifted. So definitely it is expensive task. Yes. And then why we have to go for linked list? So definitely it have some advantages. Yes, what are those? Number one is dynamic size. What is that? In array it is not dynamic in size, we know that. But here the size of the list doesn't need to be mentioned at the beginning of the program. Certainly dynamic memory allocation and deallocation. And next one is ease of insertion and deletion. We will see with the example. Because as the linked list doesn't have a size limit, so what we can do? We can go on adding new nodes and increasing the size of the list to any extent. So these two are the most important advantages of linked list over arrays. And of course, linked list also have few drawbacks when comparing to arrays also. So first one, there is no random access of elements. What is that random access of elements? We have seen in array, we can access any element using array index. Yes. For example, array is a is an array, integer array. I want to access sixth element. How I can? No need to worry. Simply I can mention the index. For example, a of 5 I can give. A of 5 is nothing but I can access the sixth element using the array index. But whereas in linked list there is no random access of elements. And next one is extra memory space for pointer is required. What is extra memory space? We will see with example. Okay. This image shows a simple representation of linked list. Okay. Here a whole linked list is represented by a header node. Yes, that is, whole linked list is represented by a pointer. Yes, this first node is called the head. Okay. If the linked list empty, then the value of the head is null. Okay. The whole linked list is represented by a head node. Got it? And you can see here node is a major element in linked list. Each and everything here I am pointing is a node. Here each node consists of two parts. You could see each node consists of two parts. One is data part, another one is reference part or pointer to the next node. Okay, that is, it stores the address of the next node. Okay, so this is simple representation of linked list. So here a major element is a node. Each node consists of data and an address which is pointing to the next node. Okay, address part that contains the address of the next node. And we have one header node which points the first node of the linked list. Got it? And another example, definitely you will understand better by seeing that. See, it is just an example. It is not exact number. For your understanding you brought, it is just an example. So as I told, there will be a header node which points the first node. Yes. See how many nodes are here? Here we have 4 nodes, that is 4 different values. So first part is data part, second part is address to the next node. Okay. For example, this is the first node we created, that address is, say for example 3200. This is just an example. So next node I am creating, the data part contains value 3 and that node's address is 3600 for example. Now how I can make link? For example, this is first node, my data element is 15. So what is this value? This is pointer which is pointing to the next node. So next node's address I am putting here. So obviously I can make a connection to the next node. Yes. So here is the second node. This is third node. Third node address is what? 4000. So in the previous node's address part, I am putting this address value. Obviously my next second node got connected to the third node. Let's go on. Understood? So this is content part, our data part. This is address part which is pointing to the next node. And always there will be a header node which pointing to the first node. What is the first node's address? 3200. So that will be stored in your header part. Why? Because we have to access the first node at any cost. Yes, to access that first node, we are storing the first node's address in the header part. And always the last node of a singly linked list which points to null, because there is no more elements after that. So to point that we are putting null. Got it? Clear, students? This is a very classic example. data part, address which is pointing to the next node. Next node's address will be stored here. Next node's address will be stored in previous node. And there will be head node, and also last node's pointer will be null because there is no more element to point. Got it? Next we'll understand the insertion, how the insertion taken place in linked list. First we'll try to understand logically, then I will explain with code. Okay, so what is first thing? Inserting a node at first position. Why? What is that inserting node at first position? So in just 5 minutes back only we have seen insertion deletion is very easy in linked list. Yes, so I can insert at first position, I can insert at last position, I can insert anywhere I want. So these are the different kind of insertions in singly linked list. Okay, we'll see with example, try to understand logically, then we'll proceed with program. Okay, so this is example linked list representation. So how many elements are there? 1, 2, 3, 4, including header is 5. Yes guys. So first node contains the value of 40, second node contains value of 50, third node contains value of 60. Okay. Since this is the first node, it points to the second node. What is the second node's address? 300. So I am putting in the previous node. And obviously third node's address is what? 400. I am putting in the second node's pointer. So as it goes on. And obviously what is my header node here? What is the purpose of header node? It will store the first node's address. What is the first node's address? 200. So I have to put that 200 into my header node. Now I want to insert a node at first position to this linked list. Okay. For example, I am creating one new node. So obviously it contains two parts. Yes, data part and address part. Say for example the address of that node is 150. Just example 150. Okay. This is the structure now. Before insertion, this is the structure. So I want to insert this new element to the first position. First try to understand logically. If I want to insert this node at the first position, what are the things to be happen? That first node should point to the second node. Also, since this node becomes first node, so this node's address I should put into header. That's all. Yes, we'll see. See after insertion what is happening. As I told, two things you have to do. So you have to link this node and the oldest first node, and you have to put this new node's address to the header node because this node is going to become a first node. Correct? See what is the new node's address? 150. I am going to put in header part, and this node's address I am going to put here. So obviously the new node will become a first node, and it have a connection to the next node, and it have a connection to the next. Okay, and my header node points to the first node. Got it guys? Very simple. So same thing you are going to implement through programming logic also. So first try to understand this logical part. Next, inserting node at particular location. As I told, I can insert first position, I can insert last, I can insert any position wherever I want to insert. Very easy here. So we'll see. Very simple example. Same kind of example. I am having 4 nodes. Okay, 40, 50, 60, 70 values I am having. And I want to insert one new node at the second position. Okay, this is first node. First node is pointed by header node, obviously. The new node I created, I want to insert at the second position. How it is possible? First try to understand logically. If I want to insert this node at the second position, I want to make connection this node and this node, new node. Also from this node to this node I should make it connection. How it is possible? Just by changing the reference. Yes. So new node's address I should put here so that this node will get connection to this node. And whenever I am creating new node, the reference port will be null initially. because it is just a new node. It is not pointing anywhere. So initially data part will be there, but address part will be null. So later, based on the position, we have to change the link. Yes. So here where I have to link, I want to link to this node. So this node's address I can bring here. So you just see this representation now, you will understand better. I am just making connection to this node and this node. Now this new node becomes the second node. That's all. If I want to insert at the third position, here I should insert. So same kind of connection I should make. Understood? Is that clear, guys? Hope you will clear. Next, inserting node at the end. Okay. So again, it is very simple. This is an initial structure. Before insertion, I have 3 elements. Okay. Last, at the end, I want to insert new node. As I told, new node, data part will be there and address part will be null because still I didn't connect to anywhere. So if I want to insert this node at the end, what are the thing I should do? I should make connection between these nodes. I should make link between these nodes. Okay, how I can make link between these nodes? Okay, since it was last node, it marked as null. But I want to make connection between these nodes. So this address I am going to put here. So obviously there will be a connection between these two nodes. Since this is last node, I don't want to edit anything in the address part in the new node because there are no more elements. So no need to change anything. Understood? So this is how I can add a node at the end. That's all, guys. Very simple way I explained. Okay, what we have seen, so we know the type of data structures, linear and non-linear. Under linear we have stack, queue and linked list. Already we have discussed enough about stack and queue with its types. It is stack, last in first out, queue, first in first out. What are the types of queues? Circular queue, normal queue and double-ended queue. We have seen with codings, with the examples, we are good enough in that. And why we have to go for linked list? Because we have to overcome the array limitations. That is, the size of array is fixed, whereas in linked list it is in dynamic in nature. In array, insertion and deletion is little expensive, whereas in insertion, deletion in linked list is very easy. These are the advantages. And of course linked list also have some drawbacks. We cannot have any random access here and we need extra memory space for pointer because we have seen, yes, each and every node have data point plus reference point. Yes, guys. So definitely extra memory space for a pointer. So this is some simple representation with simple example, and we can insert at any position. For example, first position you can insert, last position or in middle position or any position you want you can insert. So this is just a simple example how we can make insertion at the first position in a singly linked list, how I can insert a node at a particular location, and how I can insert a node at the end. So just a logical view I have given. Please go through that in forthcoming sessions. I just include technical based PowerPoints, that is program concepts we will see. So definitely you will understand better. Thank you, students. Do your best.